Okay, this proof is going to show what to do when one of our given pieces of information is that we have perpendicular segments. So what we have to do is start by labeling our diagram. Every time, label your diagram with your given information. So to label that I have segment AD perpendicular to segment BC, segment AD and segment BC is here, I'm going to label this. Now, remember, it's helpful to number your triangles or to number your angles if you're dealing with angles. Since I already have an angle 1 and an angle 2 up here, I'm going to number these 3 and 4. If you recall, when we are dealing with perpendicular, this is the one time that we do not have the ability to go from perpendicular to congruent. Perpendicular in and of itself does not tell us congruent. Perpendicular tells us that angle 3 and 4 are right angles. So my next statement, when I come down to my statements, is not going to be that I have congruent angles. It's going to be that angle 3 and angle 4 are right angles. The fact that they're right angles leads me to the fact that they are congruent. Angle 3 congruent to angle 4. That's the first congruent statement that I'm going to use. The second congruent statement is given to me. We need 3 congruent statements. I have 2, so I have to look at my diagram for the other. Well, first of all, let's mark that these are congruent angles. Then I look at my diagram for my final congruent statement. I have no vertical angles, but I do have the reflexive property. So I will label the reflexive property, and I will come over to the side and I will write in that segment AD is congruent to segment AD. Reflexive property and vertical angles are always things that we can assume. The only things we can assume when we're looking at our diagrams. I have 1, 2, 3 congruent statements. I'm ready to write my proof. This proof is going to be 1, 2, 3, 4, 5, 6 steps long. I always sketch out what I'm going to have as my proof up here, then I can write my statements. Your statements can go in exactly the order that we have up here. Segment AD perpendicular to segment BC. Your second statement would be that angles 3 and 4 are right angles. Your third statement would be that angle 3 is congruent to angle 4. Your fourth statement would be that angle 1 is congruent to angle 2. Your fifth statement would be that segment AD was congruent to segment AD. And your sixth statement, now that you would have had your 3 congruent statements, you have enough to prove your triangle is congruent. That's your final statement here. So 6 would be triangle ABD congruent to triangle ACD. And again, the next tricky part comes in writing our reasons. Anything that is given to us. Basically, these 2 things are given, get the reason given. So segment AD perpendicular to segment BC, given. And angle 1 congruent to angle 2 is given. The rest, we have to come up with other reasons for. So for 2, 3, 5, and 6. Start at the top. We did this on our proof guide sheet at the beginning of our proof section of chapter 4. Perpendicular tells us that we have right angles because perpendicular segments form right angles. We need to write that as our reason whenever we start with perpendicular. Right angles are 90 degrees. We know that if it's 90 degrees, all of them are 90 degrees. So that's why we can go straight from right angles to saying that our angles are congruent, because all right angles are congruent. Almost there. We have two reasons left. Segment AD congruent to segment AD. We labeled that because we know we can assume reflexive property. We name that reason as reflexive property. And the final one is always tricky as well. How do I know these triangles are congruent? I have side, side, side congruence, side, angle, side congruence, angle, side, angle congruence, angle, angle, side congruence, or HL congruence. Hide one of your triangles. We don't need both of them to determine this. We've already labeled them. So if I hide this triangle and I look only at my triangle that's on the left, I want to figure out, do I have all three sides labeled? Well, no, I don't have these two sides. So it can't be this. And in fact, I only have this side AD marked as congruent with something. So I don't have two sides. It can't be this. Okay. I do have two angles marked. So it could be angle, angle. It could be angle, angle. HL congruence means we have a right angle, which I have, but I need two sides, hypotenuse and leg. We already decided we only have one side. It can't be this. Then it comes down to these two. We need to find out where that side is located. Is it the included side, so the side touching both angles? Or is it a side that's not included by my angles, touching only one angle? Since this is the side and it does connect my angles, it touches both, it's the included side, I use my angle side angle. If it was one of these sides, BD or AD, it would only be touching one angle. Then it would be angle, angle, side. Since it is touching both angles, it's the included side. My reason is angle, side, angle, congruence.